Today we're going to take you into the world of 3D. 3D capture of the body using Kvest, and 3D capture of the ball and club using FlightScope. When we replay the animation, there are some numbers and measurements that we're going to take a close look at. H-plane, V-plane are two very important numbers, and numbers that are easily correlatable to the Kvest data. H-plane stands for horizontal swing plane. Horizontal swing plane is the direction of the swing at the bottom of the arc. V-plane stands for vertical swing plane, is the angle that the sweet spot moves on at the bottom of that arc as well. These two numbers, along with angle of attack, are the ingredients which produce the club path. So Patrick was hitting this shot off the ground with an iron. So we have a negative angle of attack. So the direction of swing would then need to be facing a leftward direction. Now here's what we mean by that. At the bottom of the swing arc, there is a stabilized or functional plane of the club that is going to have some type of direction to it in relation to the target line. When we're hitting shots off the ground with a negative attack angle, the direction of swing is going to need to be leftward to be able to offset the downward angle of attack. So when I look at this number Patrick has, 5.9 degrees to the right, I know that there is something going on in his swing that I'm going to look for in the body data that is creating a severe rightward path of his swing. We're going to look at kinematic sequence, pelvis bend as well. Now before we do that, just so you know, there is something extreme taking place here. Not only do I want this number to be about 2 degrees to the left, we're going to look for this number to be about 60 degrees, the vertical swing plane. So there's something taking place in Patrick's swing that's really steepening the angle the club is swinging on and shoving it out right of the target line. So now I'm going to turn it over to my friend Tony Morgan, PGA professional with Kvest, and he's going to take a look at some of Patrick's body data.
Thanks, Mike. Now let's take a look at Patrick's Kvest data. And what we really want to do here is we want to find out how Patrick's body was moving in 3D so we can really start to learn why that club was going too far out to the right in his downswing. Now we're going to start with a kinematic sequence graph. And what this graph does is it really allows us to see if the swing is efficient or if it's not. Once we determine if it's efficient or not, then we can really start drilling down to find out why the club was doing what it's doing and what might be the causes as well, some of the efficiency issues, which is why so many of our golfers get injury throughout their career. So the first thing we're going to take a look at is his kinematic sequence graph. So this is measuring the pelvis, the upper body, and the club throughout the golf swing. Basically, how fast they're rotating. That's all this graph's looking at. What we're going to key in on here is the transition sequence. We're actually going to zoom in right now on that particular area so you can really see what's going on. Now what we'd like to see in an efficient golf swing is we'd actually like to see the red line of the hips cross first. The next thing we'd like to then see is the green line or the upper body cross second. What we can see here without going into too much detail is we have some inefficiencies in the transition sequence area. A lot of times this will cause path and face issues coming into the impact area. So what we want to do now is we actually want to drill down a little bit further. We're going to click over here on pelvis bend, and we're really going to focus now on this graph to find out what's going on with Patrick's ball flight. Now we can see with an efficient pelvis bend graph, we'd like that to start around 20 degrees. And what this is actually measuring is how much tilt a player has of their pelvis at address, and then what happens to that tilt throughout their golf swing. Now we can see here his bend starts around 20 degrees. Now that's really good. Now what we see is as this graph starts to go back, we'd actually like to see the graph come down. We'll actually see a little bit of a jump coming through the top area, and we'd like to see this graph finish slightly positive. So if we pull up an example graph here, and what you'll actually see with an efficient graph is there's a little jump right here through the transition area, meaning as the player goes into their downswing, they'll actually sit down into that lead foot. Also with an efficient swing, the pelvis bend will finish around 5 degrees. So there's two things here with Patrick. We don't have the jump, and then also as Patrick's coming into impact, we're actually seeing the pelvis come too far underneath, which is why as he comes underneath, that club has to go out too far to the right. So let's do a little biofeedback training with Kvest. Let's see if we can get this pelvis bend to be more effective, and then let's see how that changes the data on FlightScope. So now we're here with Patrick, and we're going to do some pelvic bend training. One of the most important things you can do for an efficient golf swing. Now, what I've got set up with biofeedback right now is 20 degrees of pelvic bend. So as Patrick gets into a good neutral posture, you'll actually hear the tone from the 3D animation. It's then set up for him to go into the top of the backswing and continue to keep that tone. He's got to keep a nice engaged core to make that happen. The third part of the drill is to make sure that he transitions efficiently and he gets back down into a range where he can actually feel some good ground force into that lead leg. These are some things that we saw with his graph that he was not doing that was causing that golf club to come too far out to the right in his downswing. So we're actually going to do a little training here. We're going to capture another golf swing and see what kind of changes we can make. All right, now that Patrick's done some biofeedback training and we've captured that golf swing, let's take a look at some of the changes that we've actually made from that training. I think it's always really important when you do any type of training with your students or on your own golf swing, we want to make sure those changes are actually translating when they're hitting a shot. All right, so we can actually see here that they did. So Patrick's pelvis bend graph started at 20 degrees. We know that's a pretty neutral pelvis in the addressed posture position. But what I really like now is this graph goes down. That tells us he's maintaining good core engagement going into the backswing. But what's really good here is this little jump. Before Patrick's pelvis bend graph, it went down and it continued to go down. And that was him going into what we'd say is losing too much bend going in the downswing. It's usually not a good transition move where people are getting good force down into that lead foot. So with this little jump here, that's definitely telling us we're having a better move with the transition with the pelvis. And what I really like is as this pelvis is coming into impact now, before it was actually crossing negative. So this pelvis through impact was actually really coming underneath him. And now we've at least got it back to 0. It was -5 before. So these are things that will really impact the direction of that golf club coming into impact. And the more this line goes negative, a lot of times we'll see that's when that golf club really starts to swing out to the right. From here, I'm going to turn it over to Mike so he can talk about the impact of making this bend graph more efficient, what that actually did to his club direction throughout the swing.
Now let's take a quick look at what that one swing did and if we had any changes with the ball and club data. A couple of things jump out right away on the screen. Number one is we had a serious reduction in the V-plane. If you remember before, it was a much higher number. And I'm going to suggest to you, as a result of that, we had a major improvement in the club face. I'll get to that, what I mean by that, in just a second. As for the H-plane and the path, you're going to notice here that they're almost the same number. They're within 0.1 of each other. This tells us that on this particular shot that Patrick hit, based on either ball position or what he was doing on this particular shot, it was a pretty good shot based on the flight that you saw, that his angle of attack was very close to 0 for this iron shot on this particular circumstance. That's something we might start to work on as we started to improve the swing direction even more to the left. You can see a slight improvement, less severe to the right. But the pelvis bend correction that we made in just one swing after some biofeedback training was in the vertical swing planes. Let me give you a little synopsis of what's meant by this. When Patrick was swinging, his move to where he lost that pelvic bend so severely before impact created a golf club that came into contact with the sweet spot of it very vertical to the ground. The vertical swing plane measurement is a measurement of this sweet spot relative to the ground. So by improving his pelvic bend, on the very next shot that we measured, this number came in much more normalized, especially for Patrick. Usually when we're hitting a middle range iron, we look for that number to be in the 60 ballpark. Patrick, a little shorter in stature, 56.3 is a decent number for him there, especially in just one swing after training. Why did this improve the club face? We didn't change his grip. We didn't ask him to do anything with the club face. Reason being is, when a golfer extends their back that much and the club gets that vertical, the lead arm and club start to lose their offset angle, and it makes face squaring a lot more difficult. So Patrick, when he was getting much higher vertical swing plane numbers, losing all that pelvic bend, had a chronic club face that was coming in open due to the fact that the lead arm and club was losing its offset angle into the contact. So by restoring his vertical swing plane to a better number, to where the club came in much more normal to the ground, we restored some type of normal angle between the left arm and club, and it allowed him to square the face better. If I laid this club on a table and came in to swing, when I'm coming in and squaring it up to the table, my hands would go below the table. If my hands went above the table, you could see the club face would be left open. So our ultimate goal for Patrick, working on this pelvis bend, was to move this swing direction to the left. But you could see we really improved his vertical swing plane angle, and as a result, we improved his club face. So Patrick right away experienced a much straighter ball flight just from that one stature. As we went on and we started to improve on the next couple of swings, I would then start to continue to see how I would want to work this horizontal swing plane more to the left and get that angle of attack a little more down. That's how we work 3D motion capture of the body, 3D motion capture of the club. You just witnessed one small segment of training and a one swing difference, and we saw some great results.